So let me go ahead and just switch over to my scene here. Hey guys, I'm Steven, and we are going to kind of look over some of the work I've been doing on the controller refactoring that is the last little bit that we need to do before we get our latest release out. We've been working really hard the last couple days to get hands working and everything like that, which is great. So for the most part, we got that going. But today what I'm going to be looking over is this issue 494, which is our input system profile and controller mapping refactor. Really, the stuff that is supposed to be for this is we wanted to make it a lot easier and reorganize some of the data in our profiles to make handling controllers a lot easier, but also the setup phase, but also in code. So for us, we were doing a lot of like cross-referencing and having to like loop through these lists of definitions and stuff. So I found it kind of tedious and it didn't really make much sense. So what we're going to do is we moved a bunch of stuff to our global options directly into our input system profile. And then I also went and updated how our how many profiles we have in that main profile. So it's a lot cleaner now. So it actually looks pretty much like this, where we have our focus and gaze provider. Those two things are required. And then an optional gaze cursor prefab, our global pointer settings, and then our global hand settings. And then really there's only 4 profiles that we need to set in the input system anymore. Our input actions, our speech commands, our gestures, and then our controller data providers. Our controller data providers, that's going to be all of the different platforms that are going to be registered with all of their individual controllers that they manage. So to kind of give a little bit closer look at the hierarchy inside of what our controller data provider looks like. Controller data providers profiles, they're just the data provider for input using a specific library, like if we had Windows Mixed Reality or Lumen or Oculus. And then each one of those has its own mapping profile for each individual controller type. So I think for Windows Mixed Reality, we have the HoloLens input, and then we have our spatial controllers for both left and right hands. So underneath that, we'll have our controller type, our handedness, and then an array of interactions for each of the individual controls that controller has. It's just a distinct input pattern that can be recognized as a physical control mechanism. An interaction only triggers an input action when the device's raw input will match the criteria defined by the processor. So for this, we're actually borrowing a lot from Unity here. Unity's new input system has this concept of processors that you can register with each control mechanism, that you can essentially say, okay, well, I only want to listen to values between this range, or I want to invert my values, or do some other additional processing on the raw input. So that's one of the other big changes with this pull request as well that we're going to be doing. So one other thing that we did is we pulled the pointer profile from the root into the individual interaction mapping for each control mechanism. So every control mechanism that is of a 6DOF or a 3DOF value will essentially have its own pointer, to say. So if a control mechanism like the spatial pointer or any other, like maybe any other 6DOF control, we can start adding pointers to them. And this could even be something like a finger on a hand. So we'll be able to do that. This will also have a human readable description so that you could name the control mapping so you understand what that looks like, and that will show up in the controller map as well. The axis type, which denotes whether it's digital, raw, 3DOF, 6DOF, dual axis, which is like a thumbstick. The input type, which is essentially like another descriptor just to help define what those are. And then also the input action that will be raised when the raw device input matches the processor's acceptance criteria. The processor, which is the operation that the device applies to the input value. And then the state change type, which influences when state changes will happen So there's going to be two types to begin with. One is continuous, where we just always raise changes for the state of the control. And then also trigger for things like buttons. So when you press a button, you only want it to be active maybe that one frame and then go back. So that'll be interesting. There's also some interesting stuff there because we may want to do a combination of both. I'm not sure exactly if we'll take full advantage of the state change type to begin with, because I think we do already have some things that we're doing to kind of control that in the controller's implementations themselves. So that's something we need to take a look at going back. Oh, and one other thing, each individual controller mapping will have its own controller visualization profile as well. That was another profile that we had that was doing like a global thing, where we actually wanted to pull that out and have it on each individual controller. And then also the controller data provider profiles can have additional platform specific options serialized directly into it. So we'll take a look at that. Here's some terms and concepts from Unity's input system that we're kind of borrowing from. I'm not really a big fan of their new input system so much. I still don't feel like that they are providing a platform agnostic interface for doing this. They did borrow a lot with the input actions, which I thought was kind of nice and flattering. And I did talk to the main engineer for the input system for a while about kind of seeing that. They do got some interesting concepts, but I think for the most part, the thing that I don't like about the input system from Unity is that there's no way to add native input mechanisms or registering your own libraries to use for input. So it's still very difficult. You still have to go through the editor, and a lot of the stuff, you know, is still in the editor when it should be more exposed, essentially. So a little frustration points there, but that's the reason why we still have our own input system within the toolkit. Not only that, but I do like the concepts that we have where we define the actions and then just apply those actions into the UX directly. So I'll go over the new UX a little bit here. So if I go into the input system, this is what our profile looks like now here on the right hand side. We have these drop downs, so it makes it a little bit cleaner initially, so you can kind of drill into what you need. The biggest change here is the controller data provider's profile. So we have a bunch of these here now, and now if you we have profiles for each of the controllers data providers themselves, and these will have the individual controllers that you can register for that platform. So for example, for the Unity input, the joystick controller, this is for all joysticks within the Unity editor. The OpenVR controller is also the same in a way, but essentially we have a generic joystick controller profile and then an Xbox controller. Let's see here. And these are currently empty, but I'll go back and check those out here. I probably just need to finish implementing those. For the Windows Mixed Reality controllers, we have the HoloLens controller, the left Windows Mixed Reality controller, and the right one. And then we have additional Windows-specific settings for this data provider. So we're able to get really specific about platform settings that maybe other platforms don't have available. Actually, let's go back here and take a look at the right one here. It looks like the interactions aren't actually getting created like I want for these. So I'm going to go back and look at these, make sure this is working correctly. I don't think it is. Let's see here. Yeah, it doesn't look like that's working like it should be. These should be populated and they're not. So maybe it's not serializing the data correctly. Let's see here. So I bet the references got broken somehow when I renamed these before when I was working on it. I'm going to go ahead and just delete this folder and recreate these and kind of show you guys exactly what's going on here. So if you don't have a controller data provider, just clicking the add button here will generate the default input actions for you. Here we go. So this is what one should look like when it's filled out. So I think maybe I broke the references somehow. But you actually have the controller type, which you can change if you want, although I don't really suggest changing these two values if they're already in there for you. For the most part, these are defined by the data provider's controller definitions. So we know the definitions for each of the controllers we expect. And really this is here in case you want to add your own custom controllers to the data provider. But for the most part, you may not want to change these once they're set. They're really just here in case you wanted to customize a new controller type, not an existing one. Again, we have our controller type, the handedness, and then the visualization profile for that controller. And then underneath here, we have each one of the button profiles. So these all are essentially the button mappings that we would have. So before, we had this controller pop-out window that had a whole table. So now it looks more like this, where you have to go into the individual profile, and then now you can kind of set it up. So if you wanted to know for the spatial mouse position, you wanted to have a specific action for that. So we'll say it's the pointer pose, and then maybe a key code. We won't need that. We won't need any of this. This is going to go away. The access code invert. These are going to go away. This is going to go into our processor. And that's one thing I haven't finished yet, is adding a way to define the processors. This kind of could be better. I do like Unity's input system, the new input systems. Let's see here. They do have a nice, trying to find the window here for their actions. They do have this nice window here, and I would love to have something similar to this where we can get kind of closer in, and maybe that's just something we could do later when we have our own window for this. But really this is just the inspector window. I do want to have a mixed reality window specifically for navigating profiles and customizing things, so we'll do that at some point. Right now I know it's not pretty, but it works. So these are all of the control mechanisms that you would have. And then we could do that for every single one of these other platforms. So for example, for Oculus, and I know it takes a second to generate these out, but it fills everything out for you here. For the most part, when you go to configure the toolkit, we'll already have all of these things configured for you. So the only thing you have to do is just press Mixed Reality Toolkit Configure, and you'll get all of the default profiles at the beginning. Really, this is if you want to create a new copy of all of these, you'd be doing something like that. So here, I need to also finish this. So I'm actually supposed to be getting the controller image and a nice layout for each of these control mechanisms. So that's one other thing I need to finish. And then let's see, I'm kind of curious why those other things got broken, so I do want to take a look at that as well, because those should have been showing up before, and I'm thinking maybe they didn't get serialized into the controller for whatever reason. So I'm going to actually save my project, close the window, and then relaunch just to make sure that those references are still still working correctly. Let's see here. All right, so let's take a look. Let's make sure our mouse controller profile, yeah, that's not getting serialized correctly. So we do have a bug that we got to fix first before we do anything else. So let's see here. Let's take a look at this file. I bet it's just empty. Yeah, so we're not actually getting this this array set and serialized properly. The same thing with our controller type and our reference and our handedness. So let's fix that first. So I do have one bug I need to go ahead and take a look at. So what do we got going here? So let's take a look at the inspector for this class. Once Visual Studio catches up here, so we'll take a look. All right, so this is the inspector for our mixed reality controller mapping profiles. And what we do here is we have two lists. We have some interaction mapping profiles, and we're doing a bunch of stuff here. But this isn't exactly where the magic happens. The magic actually happens in another class. Let's see, it's this base mixed reality controller mapping profile inspector. No, not this guy. I want to see where we're referencing this at. Here we go, our data provider inspector. So this is our base mixed reality controller data provider profile inspector. So this handles rendering all of the data providers profiles, which is, if I go back here, it is actually up one level, and it's this guy here. So it's this one where we show all of the different controller mappings for our platform. So, oh, that's not what I want. I want to go back to Visual Studio. All right, so what we do here is if we haven't set up the default controllers, we actually grab the default controller options off of our individual controllers, all of the ones that are already defined, and that is actually defined in each of the data providers. So for example, for our mouse data provider profile, if I go here, we actually have a controller definition here that we've set up. We pass in the type of mouse controller, the handedness, and whether or not we're supposed to be using a custom interactions. And what that flag does is whether or not it should show before the grid of actions that you saw in the controller pop-up window. But now, because what we're going to do now is instead we're going to see if we have an image for that controller, and we'll probably just depending on whether or not we have a controller image, we'll render that. But we get the default controller options, and then we iterate through all of these and create new scriptable object assets for those, and then we set them. So it looks like that this data here isn't getting set properly. So that's the bug is probably in here. Let's see. For the interaction mappings themselves, we also do with something similar for each individual mapping. So it's kind of it's kind of a couple for loops in here. So we get that here. Set the default interaction mappings after. So maybe that's part of the problem, is we do this after we set the object reference. But then we're also not serializing the data either. We could probably move this up a little bit. Let's do that here. So I'm going to move that up a couple lines, and then I also want to add see default profiles. I don't know if that actually, yeah, so mapping profile scriptable object. And we're going to apply our oh, here we go, serialized object. That's what I was looking for. So mapping profile serialized object, and then we apply the modified properties. One other thing that we may need to do is actually, from the instance, we need to actually create the scriptable object reference and then actually set the serialized properties on that. It's probably what we should be doing. Let me try that instead. Let's see. We just pass in the instance, then we get our new serialized object, and then with this we would have to do the same thing, find property and do all of the other stuff that we need to typically do for that. Let's see here. and this will just be this, but lowercase. Actually, you know what yeah, that's fine. Typically I like doing the name of for these, but I don't think I have access to the things that we want to do. We also want handedness, and we also want the flag for use custom interactions. All right, so now we got these. Let's see here. I think now we want to update this to use. Actually, oof. I think I need to actually find the reference. Find property relative reference. I don't think that would work quite right. Okay. So string value would equal the controller type. And I think we could say reference here. Or I'm sorry, system type, not system exception. We can get the reference by passing in the type using the static method here. That should be what we want for that one. Let's see here, handedness property, int value would equal the same that we'd be passing it, but we want to cast it. And then our use custom interactions property boolean value would equal the value we pass in. Okay, now here's an interesting thing. Do we want to pass in the instance to set the default interaction mapping? Or do we want to pass in this serialized object? I'm thinking maybe we want to pass in the serialized object, or else it may not set the values that we want. We'll say instance, I'm sorry, not instance, we'll say mapping profile serialized object, apply modified properties. I think we also want to update it before we start making any changes to it as well. All right, so instead we're going to pass in, instead of passing in the instance, we're going to be passing in the serialized object for our instance of our mapping profile. Oof, but here's the thing. I may move this up and make this a this is going to be kind of annoying, but we're going to make this a local method function. We got some advantages for doing this, and I'll kind of show why that here in a minute. But mainly is that I don't have to go and do this every time again. So let's see here. I'm also going to get the serialized object property for the interaction mapping profiles. All right, and I'm not even going to pass in anything here. Let's see, this mapping profile. We're going to actually call the instance here. And instead of calling this instance, we're going to say so that's good enough. And then we also want to update this since we're already in another for loop. Let's see here, anything else? use of unassigned variable mapping profile might not be initialized before we do something. Oh, I see. So we're actually going to be using this here. I'm going to say new system type property string value. So this will actually create a new type from our thing here, and we'll actually say this. Actually, I don't know if we really need that or not. And then now we can also use the handedness property here instead. But let's cast this to handedness. We'll need to do the same thing here. Not a big fan of using these serialized objects, but I have a feeling that's really the only way that we can do some of this stuff, unfortunately. So this will be interesting. I don't know how to add a whole collection to a serialized array, so this will be interesting. First thing we'll do is we'll clear the array. I have a feeling this won't stay either. It seemed like it did though. In the other one, it seemed like it did. See if there's a way. Let's see what array things there are. We can get elements. We can insert elements at indexes. We can move the array element. We can add individual array items. I think I actually have to loop through all of these, so that'll be kind of interesting and annoying. So instead of passing, since these are all method, like local methods, instead of passing this back, I'm half tempted to continue to use our local method value. So give me just a second here. I'll think about this all the way through here. So I'm going to remove the return value for this. And let's see, we'll just make this void now. So we won't be returning anything. We'll just be serializing it directly into the object. And then we'll still need our control, we'll still need the reference to our properties, except this time we'll be adding an index at an array. We also won't need this. So insert array element at j. Then we'll have to get the element, because I don't think that this actually passes back a serialized object. So we'll have to get the serialized property back. Then the interactions property. Wow. Believe we can say object reference value equals our new asset. All right, pretty sure that should work. I think for the asset, I also need to get a serialized object and assign the mapping profile to it as well. So let's see here. Actually, rename this to be something a little bit more descriptive. Interaction mapping asset. Seems more descriptive. Do the same thing for the one that we created up here. Instead of instance, we'll say controller mapping asset. All right. Let's see, I think I still need to make a serialized object out of this asset, so do that first. Let's see. Serialized object. And we'll have to do the same thing again. Find property. This time we're looking for just the interaction mapping itself. This is just an individual thing, so I don't think we have to actually, let's see. This could be more tricky than I thought. Let's see if this works first. Let's see, interaction mapping property. See, this isn't gonna work because I think this is fine the way it is. It looked like that those references didn't get broken for the one underneath, so I'm not too worried about this. I'm just going to set the object reference value and see if that works for us. Okay. Just going to go ahead and delete all of the profiles we've created so far, and we'll start over. All right, so let's take a look here. Let's drill back into where we were at. Let's go ahead and create a new one for our mouse profile. Okay, so it looks like it created these correctly, and then it looks like it also set the initial data correctly. So the next thing to check is just to restart the editor to make sure that those references get serialized. The other thing I can do too is actually check the SDK package and see if we actually had any files written to disk here. Let's see here. It just says everything was deleted. Oh, here we go. Should have been just renamed. Here we go. So no changes there. That looks completely new. But it looked like it added our interactions correctly, so that's good. And then it also added the rest of the data correctly, so that is also good. So I think we fixed that. Let's also take a look at what's inside each individual interaction mapping to make sure that that is also working correctly. Looks like it is. Okay, so I'm pretty sure we fixed that bug. If you guys have ever used local functions, essentially it's like nesting functions within a function. It's kind of useful in some cases where you don't want to have to like pull out a method and use a more global value. So like for a class, you have these class level values and like variables that you could use, but sometimes you don't even want the variables to be scoped out to the class, but only within the method that you're working in. So this is actually very helpful for that reason. It does create closures, so it's not as performant as you may want. Maybe it'll hold on to the object references a lot longer in memory. Sometimes you may get more garbage collection calls for these things, but for the most part, it's pretty good to use. I wouldn't say that it's a terrible thing to do. The only thing I don't really like about it is that you start getting really far over to the right when you start doing these things. All right, so I think that works the way we want it now. Let's take a look at our controller data provider for our mouse again. Looks like these are getting set correctly. Although now we are getting an exception on our individual thing here. ID cannot be 0. Okay. So what's going on here? Looks like when we're creating our mapping value, maybe this isn't getting set correctly. Let's just take a look at what this looks like here. See our serialized data. Maybe it's not getting serialized like I thought correctly. It looks like for the interaction mapping for this one, the description is blank, which I think that's fine, but our input action has a blank GUID and a zeroed out ID, so that's bad. And this should also be none for the default one as well. So let's take a look at what we can do to fix that. That's why it's getting mad here, is because typically when you create a new input action, the ID should, if the ID is 0, then the description should be none because we don't have an input action. So that's what is getting called here. Let's see here. So I believe we're creating an empty one. Let's take a look at our class here. So this is creating a new, let's just go ahead and add none here. I thought that it was supposed to default to none, but I guess it's not. Doesn't seem like it is, like it's supposed to properly. But the default constructor is what was messing up our generation here. So I'll go ahead and fix that, and then I will delete these and try again. Okay. Let's see. Final round. This time let's do the Windows Mixed Reality controllers. All right. So let's take a look at this. Let's open it up in the Explorer, and we'll actually take a look at the serialized data directly. All right, so this looks a lot better. It's saying none, and we're getting a zeroed out GUID profile for that. And then also our description is coming up none as well, so that's good. Everything looks correct here then. Let's see here. So for our spatial pointer profile, the description for the interaction mapping shouldn't actually be none. It should be spatial pointer. So it looks like that this actually isn't working 100% the way that we want it to. So which was my speculation when we were looking at this before. So let's see here. If we go back to here. This is where we were having that problem. I have to do the same thing again, where I have to get all of this, all the serialized object data, and then set that, and then iterate through each of these. So not going to be fun. Let's see here. So essentially what I need to do is get the reference to the interaction mapping, but not only that. So I go to the mapping profile. We need to get this serialized reference, but not only that, but we need to get the serialized references for each one of these fields within the interaction mapping structure itself. So we need to get to the description, the state change type, the access type, the input type, and all of these other things. But to be honest, I don't know if I want to do all that just yet, because I do have a little bit more work I want to do in this class, which was adding the processors. So I might go ahead and do that as part of this work. But before I do, let me go ahead and check in some of the work that I've been doing so far. I'm not going to check in the changes to the SDK. Really, I'm more interested in changing this stuff here. So let's go ahead and add this none interaction. And then also, let's take a look at this. We just moved this up, and we created the serialized properties. So I'm going to go ahead and just check this in. Fixed issues setting the interaction mappings in the controller profile. All right. So we got one bug down. Let's go ahead and commit that, push it up, and then we'll start work on the next thing that we're going to do. Let's see here. So I'm going to go back and just kind of talk about what the processors are and what they do. So the processors is essentially going to be what we're going to be taking from Unity here. It's an operation on the input system that applies to an input value. For example, invert processor inverts the floating point value from that raw input to what we want to essentially send out to all of our people listening to our input action. So for Unity, what they do is they have a couple of default ones. They have an access dead zone, a clamp, an invert. They invert vector 2 and vector 3. They have some normalization and scaling things, and then a stick dead zone. Wouldn't that be the same thing as the axis dead zone? Looks like it's a single axis, whereas the stick dead zone is a dual axis dead zone type. I wonder if we want to do the same thing with the 3DOF axis. Anyway, I really like what they're doing here, where they're able to add modifiers to the processing scheme, essentially. So we're going to take a look at that, how we can do something similar. I'm not even going to look at their code. I just like the ideas that are behind it. So I'm just going to maybe kind of recreate a couple of these without even looking at the code, just to see if I can do something similar. So we want to be able to serialize which kind of processor we're going to use in the interaction mapping. And this is going to replace a couple of fields that we already have. Like, for example, we have invert x-axis here. These will go away in favor of the processors themselves. Let's see here. And then where are we using this exactly? So we're checking to see if we've inverted the x-axis for some of our controller operations. So this might get tricky. We may need to be able to query what processors are in the interaction mapping and what their states are. So that might be important to think about while we implement this. But then also, let's see here. We have whether or not the control has been activated from its initial state. So this is probably going to kind of go into this may be replacing the other control state. The change state type may replace this control activated flag. So we'll take a look at that as well. Also this updated flag. So we may need to see how that will interact or interfere. I haven't exactly thought about how the change state type is going to be used yet, and I'm not sure if we'll even use it, but it's just something that I thought that was a good thing to take from Unity's input system definitions that they had. So we'll take a look at that. Okay, so let's see here. We want to be able to apply these in the editor as well in some way. So that'll also be interesting. The processors might end up being scriptable objects, most likely. That way you can create one processor and then assign that to multiple controllers. I think that will be, at the end of the day, that's probably what we want to have more than anything. So let's see here. Input processor. And these are going to be generic as well, because what we want to do is be able to define the type of data that this input processor is going to handle. And I don't know if I'm going to actually make this a profile. I think I'm just going to make this a scriptable object. I don't think we need to make it a mixed reality profile. Let's see here. So a couple things we want to do. For the constraints for our generic type, we only want to be able to use things like the basic types. So for these data properties, we have these object types. So object, bool, float, vector2, vector3, our mixed reality, pose, quaternion. Those are going to be the ones that we only want to restrict to be types that we process within this. So we'll probably have some generic type constraints for this class at some point, but I'm not too worried about that at the moment. So let's see here. So this will be the value. And we'll probably return something out of this. Probably be the processed value. We want to make this public. The other interesting thing here as well, we may also need to have a base class that is not generic, but we'll make it abstract. Now the reason for this, and I'll kind of show this a little bit later, is because we want to essentially we want to be able to serialize multiple different input processors that have different generic constraints. And the way to do that is kind of interesting. And I've done that in a few other places for our other scriptable object profiles, specifically for the services. So if I take a look at base service profile T service extension, essentially we've done the same thing here. And what we've done is we have an array of our mixed reality service configurations, which is not a generic type, and this is serialized as a private field, but for our public getter, it is the generic type. And what we end up doing here is we check to see if our configuration is cached or not, and we go ahead and create all of the things that we need, and we actually create a new instance using the generic type. And the way that we do that is we have a T service here, so we're just essentially defining the generic type constraint in the class that we're serializing it. I'm not sure how that's going to affect our interaction mappings, but we may need to add the type constraint to this as well. And that'll be interesting because we may or may not want to do that. So we'll see how that works out for us. I think that at one point we did, and for whatever reason, I'm pretty sure that we had removed it. Let's see. Also, to organize this class a little bit more, I think I'm going to put all these constructors into their own region. We do have a lot of constructors for this class. All right, we'll collapse this down. Definitely more interested in the properties right now. I think we'll go ahead and get rid of the, well, now I got to figure out how these will affect the other places we're using the method moment, because we do need to know whether or not we've inverted the axis. So that'll be something we also have to consider when we replace these. Okay. I'm going to go ahead and also pull this out into its own class. My fear is that I'm going to have separate classes for each of these. Okay. There we go. I'm also going to make this input processor generic one also abstract as well. So we'll make sure that people have to implement these. Although I'm not sure that will work out the way that we want it to, but we'll figure it out as we go. I'm going to close a couple of these that I'm not using. I'm kind of curious about this one again. So the service configuration. This actually isn't abstract, and I'm wondering if I don't think we can actually serialize abstract classes. So as much as I don't want, I may actually just make this, I don't know if I can make this sealed and still be part of the, nope. Okay. Yeah, that's going to be frustrating. Because we want people to use the generic type for what we want to do. Oh well, it's all good. Let's see here. So for this one, we have the non-generic type, which has all of our serialized properties, and then the generic type, which essentially creates this generic constraint that we want to put onto it. So we'll see how it happens here. So let's see. Some interesting things that we'll need to know about this input processor. One is probably the mapping. No, maybe not. We want to pass in some values and then get out some new values. So that'll be interesting. So maybe we don't want to get this get value. I'm wondering if actually we want to pass in the constructor. No. Wondering how to do this. I don't think we're going to actually have a property. I think we're going to actually have a method here. We're going to say process T. And then we're going to revert, we're going to return the processed value after. That makes sense. Let's see. So we're actually going to use the reference value type here. So we'll actually process it in place and we won't really do anything with it. What is this upset about? Okay. Let's try doing our first one, which would be invert, I guess. Public class invert axis processor. And we'll say vector you know what, let's do float first. Actually, I don't need this here, I need it here. All right, and now it's going to get mad because we need to implement the missing members. So we'll say public override process, and we'll process the float values. So in order to invert our axis, what we'll do is just take a look at what we're doing currently, which is here. So when we process this, I believe if we've inverted the axis, what we do is we take the value and we multiply it by -1. All right, and I think that should just be enough for what we want to do for that one specifically. And then for our dual axis, we would want to do the same thing. Let's see here. Do I actually want to make this a scriptable? Yeah, I do want to make this a scriptable object, because then I can assign these in the inspector. All right, so I don't need the service configuration thing right now. That was just reference for earlier. Base material and service profile, I don't need that. All right, I'm back here. All right, so for our dual axis, this one we may need some additional information because maybe we want to only invert the x-axis but not the y-axis. So for this one, we may need to add additional arguments. So that's interesting. How would we do that? Well, great question. We can just serialize that directly into the class itself. So we'll say private boolean invert x, private boolean invert y. We'll add the serialized field attributes. So they'll show up in the inspector. And let's actually give these default values. Stop helping. I don't want it on a new, I don't want it all on the same line. Oh man, okay. So then here we'll say if invert x-axis, we'll take our value y, and it will be times equals -1. Oh, I'm sorry, x times equals -1. And if invert y, we'll do the same thing. All right, so there we go. Now we have our single axis processor and our dual axis processor. Okay, so what else do we want to do here? I guess we could do the clamp one as well. I kind of want to do the vector 3 one as well. I don't know. Oh, there's one other thing I wanted to do as well, is I wanted to add an attribute to this, or figure out some way to prevent some processors from being able to be assigned to interaction mappings that have a different axis type than what they're able to process. So that's one other thing that we need to look at as well. And we'll take a look at maybe how we can do that at some time in the future. Let's go ahead and add some information here. Processes, oh, you know what? Let's just take what we had written in GitHub for what this does exactly. All right, so an operation that the device applies to an input value, to a raw input value. To get a desired result. Well, to get, I don't know. Jared, what do you think for a name for this? An operation that applies, an operation that the device applies to a raw input value to get a processed value? To get a hydrator. I'm trying to think of something generic, right? So to get a more desirable value. To get a usable. To get a usable value. No, I could care less about that. I was talking about trying to figure out what the, yeah. Trying to add documentation. Anyway, thanks. I'll actually make these, I'll make these available, let's see, but only as read-only values. So the reason why I'm going to do this is because back in a couple of the controllers, we wanted to know if we were inverting the values or not. So this will be helpful in determining that, which will be nice. All right, so we got a couple of our base processor values in, which is perfect. So this is going to be our base input processor class. Ah, you're reading my mind, you know. Alrighty. Okay. Sorry, I was replying to our Discord chat, talking to Dino. All right, so let's take a look here. I think I'm kind of fine with going ahead and trying to update the x-axis things here. So let's see. We may get a bunch of compile errors for now. Invert axis code X, Y, input name. Let's go ahead and comment these out. I'm sure everything's going to get really mad. Oh, actually, sorry. I need only the inverted ones. Should the x-axis be inverted? Let's go ahead and comment that out. And then this guy as well. Oops. Messing everything up. we go. All right, so we'll get a couple of errors in places where I'd expect. Let's see. We'll come back to this class. I'm more interested in finding out where we're using this in other classes. Looks like the generic joystick provider. Go ahead and just remove this from the constructor here. All right, so this will be interesting. Instead of commenting this out, I think I'm just going to go ahead and remove this whole section out. I'm going to call this serialized properties for my field here. All right, just give me 1 second, guys. I'm just going to send out a couple tweets about me live streaming. All right, so I'm back at it, guys. Sorry, I was just trying to get out some links out there for everybody. All right, so where were we at? So we were replacing our serialized access values with the processors that we're going to do. So let's go ahead and add those now. So we're going to have an array of these input processors. And this is going to be initially null. Actually, you know what? Instead of having it null, let's make sure that there's probably always something here. The array is at least initialized. So we'll say we'll just give it a new empty array essentially. Let's see, what is this upset about? Non-static struct member cannot have an initializer. Oh, that's right. So we will come back to that. All right, so we'll say public input processor. So for this one, what we want to do is we want to pass back the generic array types. Let's see here. Kind of similar to how we did it in the configuration services. Now, I don't know if I want to do this as an array, if I don't want to do this as a list, because that actually might be easier to iterate over and to add new processors later. You know, I will do it as a list. There's no reason why not to. But the other advantage of the list is we can do a read-only list. So let's see here. So for our for what we pass back out, we can just make that a read-only list. read-only list will be input processors of type T. Let's see here. And for now, I'm just going to leave the getter empty. So this will be interesting. So now we have this type T generic constraint, but our class doesn't have it. So this will be kind of interesting on how we end up wanting to do this. I suppose one other thing we can do too is pass in a type and get the processors out for that type. That actually makes a little bit more sense to me. So instead of actually having this as a property, what we can do is have some methods on our struct that pass back a collection of input processors for a specific type. And then that would also make it so that we don't have to add a generic constraint to our mixed reality input interaction mapping class, which I'm really apprehensive about doing. So that could help. Let's see here. One other interesting thing too is at one point we were trying to figure out how to use generic constraints to get the data back out. But the problem that we were having was we were running into a lot of boxing allocations. So that was another thing. This is why we actually have all of these properties that have, even though the interaction mapping may not have the actual type that it has, which is why we added these checks in here. But it's a lot faster than if we do the boxing for our values for the generic types. So that was one of the advantages there. So let's see here. What I want to do is I want to get the input processors for a specific type. So I'm going to actually close this up and I'm going to add a new section here. We're just going to say interesting. How am I going to do this? Say we're going to actually make this public, and we're just going to be input processor, and it's going to be the basic type. It's not going to be the generic type. We're going to say get input processor for. Actually, we'll pass in the type. See here, and what we're going to do is I'm going to add the return statement. We'll return null for now. If we don't find anything, we'll just return null. But actually, I want to make this a read-only list. So what we're going to do is we're going to pass back a collection of input processors that match the type that we're looking for. So if it's a float, a boolean, or like a vector 2 or things like that. So all of the processors that we're going to apply for a specific value type. So let's see here. For our input processors, and then we'll say our count, what we want to do is if the input processors, I want to say we want to get the generic constraint for this. So let's take a look here. The way that we do that here in the inspector, and let's take a look at the inspector here. for this. Find topmost generic type arguments. Now this is going to be somewhat expensive, so we may want to try and cache these values. So we get the generic type arguments, and then we get the first one here. And this is for our service constraint for what we're doing in our configuration profile. But essentially this is what I'm looking for. So we'll get this, and then I believe we utilize this later on here, where we loop through all of this. Let's see, the system type reference. We get the constructors for that, and then we get the parameters. That's a little bit different. I don't think I'm too worried about that. Okay, so I think I got everything I'm looking for. Go back to our interaction mapping here. Generic type constraint. Type. Actually, you know what? No. What we want to do is so our generic type constraint is going to be for the input processor. And we get the type, and then we're going to get the topmost. Get generic type definition. Is that what we want? What does this do exactly? Let's take a look. Returns a type object that represents a generic type definition from which the current generic type can be constructed. I don't know if this is exactly what we want. Again, I'm more interested in the kind of more interested in this other one that we created. Let's see here. Yeah. There we go. I just needed to actually import the usage for that. Okay, so generic type constraint. So we now, that should be the generic type constraint for that. And then if our generic type constraint is equal to our type, I'm sorry, type of, I don't know if I could actually do this. Can I do this? Oh, this is an array. Interesting. I thought we passed back just the first one. We'll say first or default here. Although this is using link, and this is supposed to be pretty performant code, so I may not actually do that. I may actually just brute force iterate loop over all those things. We'll just call the we'll just look at the first one. Okay, that's what we want. So if our generic type constraint is equal to the generic type that we pass in, you know, I might not even need this. And I could probably still make this a property getter. We'll see what happens. Excuse me. All right, so if we match, then we want to add it. So we're going to have a new collection here. Is a new list of input processors. And we're actually going to go ahead and initialize this with our input processor count. Interesting. Okay. All right, and then we'll pass that back in. So no matter what, we'll always pass back a collection. Let's see here, and then we'll go ahead and input processors add. We'll add our input processors. We'll add the one at that. There we go. All right, so I believe that should give us what we need. What are we upset about here? Oh, I see. I see. I see what I did. Okay. So I need to rename these three. There we go. All right. So now we're creating a new list of our processors, and then we're creating everything, and we're passing that back. I don't like that we have to actually initialize a collection every time we do this, because this could get somewhat expensive. So caching the list of input processors for a value or for a specific type would be kind of nice. I may end up doing that. I'm not sure how I wanted to handle this yet, because this process or this method could be quite expensive later, and we may be using this in a couple of different places. So that'll be interesting on how we end up doing that. Okay, so let's take a look here. We're still mad about these invert axis parts that we're not using. Let's also go ahead and initialize our input processors list. So we'll say new list So when we create a new interaction mapping, we initialize a list of input processors if we don't have any. Okay. We need to do the same thing here. All right. Okay, so still need to handle how we're doing this. So, I might go ahead, well, no, because we have this generic type constraint here. So I don't think that we can get, I'm going to actually rename this, get input processor for type. And I don't think we can make this a property because we do have this generic type constraint. So that will prevent us from being able to make this into a property getter, which is fine. Essentially, getter properties are technically methods under the hood anyway. Okay, so a couple of questions I have about this. One, I'm worried about all the allocations every time we call this. So I want to figure out a way to cache these input processors for a specific type. And I think what I want to do is actually make this list of the generic type for this. So what we'll actually need to do here, we'll actually need to create a new input processor. We'll have to create the instance for it because it's a scriptable object. So create instance, scriptable object, create instance of type input processor, with our generic constraint. If I don't press caps lock, that would help. All right, and then we'll add our processor here. What we want to do is, I think that's about it. We do want to make sure that any values that our input processors have, serialized values, get applied to our new instance. Wish there was a way to cast these up, but I don't think there is. So we have a collection of input processors base class, which is not generic, and we're trying to essentially upcast them to the generic types. So let's take a look at that other inspectors that I had. No, actually just the base service profile. So what I did here, so the difference here is that these are not scriptable objects. These are actually, this is actually just a class. So the difference here is that with the scriptable objects, it's a little bit more difficult to essentially create instances of these objects, which is kind of frustrating. But then also, there's no way to know about the fields in our processors. So for example, if we go back to our processor, for our dual axis, we have flags here that say whether or not we want to invert the X or the Y. We want to, if we create a new instance of our scriptable object, we also need to set these values somehow. So that'll also be interesting. Let's see here. How would we do that? So we'd be losing, so we're losing some information by doing this. So we need to figure out a way to get that back somehow. I don't know how contravariance would help us understand which flags we have. Like, so for example, for the input processor, we have two flags, invert X and Y axis. We would be losing those values by creating a new instance. But if we could somehow keep the same instance and then cast that to our generic type without losing those field values, that would be helpful. So you're right, maybe we could use that somehow. Give me 1 sec. I want to add you to, I want to add the, I need to add input from the, I just realized that it has my microphone, but it doesn't have like what I'm picking up from Slack, so nobody can hear you. So give me 1 sec here. I want to add an audio input capture. Built-in microphones, USB microphones, other USB devices. No, I don't want that. A media source. Oh, here we go. Audio output capture. Here we go. We'll add the source. Hey, look at that.
Hello.
Hey.
Hi.
Okay, so now I think people can actually hear you. It's showing up now.
Nice.
So that's good. Well, I wanted to do this anyway. So we're in Discord, if anybody's wondering. We're just hanging out in the Discord XRTK streaming channel. And that is there for people to go and check out. So you were talking about contravariance. So this is probably something we could try and do here. This is where like generics kind of like are pretty interesting, right?
It's just how I know it is like covariants basically allow you to subtype, like go down the tree, so you can maybe cast like a cat to an animal, right?
Right.
But contravariance allows you to go the other way, where you can be more specific. Well, really, it more specifically, it's just whatever direction you're not going. So if you're getting more specific, it'll become less specific.
Here we go. So we have a more specific one, but we're casting it up to, I guess we have a less specific one and we're casting it to a more specific one.
But I'm not sure if that would do what you want it to do, because you still want to. I'm not sure if that would preserve the fields or what you're talking about. I don't know what the class looks like, but
well,
I don't.
we can test it out. So that's part of why we want to write unit tests for this stuff too. So we do have a bunch of unit tests that we do need to update, and that's part of the list of things that I need to do for this pull request. So I will be checking that out in just a second. So if I go back here, I still think I got my list of to-do items here. Update interaction mappings with processors, and then also update the unit tests. We'll get there, but we can use the unit test for now to test this this out. I might actually go ahead and move the unit tests up to after this. It's kind of like in conjunction with, really. Okay. But yeah, let's test this out. So let's go to our unit tests. So we do have some unit tests for our interaction mappings, and they're already failing. I already ran it one time to see what was failing. So we got a bunch of stuff we got to figure out how we're doing this. But we also still have some places where it's mad. So I'm just going to go ahead and comment these out for now so we get something that compiles. The other thing that I'm a little bit worried about is if we add these processors, I'm wondering how much overhead it will add to each value call, and like wondering if that'll impact performance at all. Because what we really want is, you know, the input to be as fast as possible, because players notice that sort of stuff, right?
Mm-hmm.
You want all that stuff to be.
I don't know what the equivalent of like inline is, but whatever the equivalent of just like having like a function on the heap or on the stack, I mean. So it just like it runs through the function.
Is a struct as well.
Nice.
Right. Or sorry, not the input processor, but the interaction mappings. This is a struct. So we're just reading all these values from memory, right? Okay, so what do we want to do? We want to test out our new get input processors for type and make sure that our flags are still working correctly like we expect them to. So let's do that. Let's go to our interaction definition tests. I'm actually going to open the source code here, and this should take us exactly where we want to go. Okay, so all these tests are failing because of what I've done to update all of this stuff. So likely everything will fail for the most part. I'll just check them out. Surprisingly, a lot of them do pass. So I haven't changed a whole lot, I suppose. Especially the inverted ones will definitely fail. Boolean change, no update. We'll check these out. I'm not exactly entirely sure what's going on to make these fail. Okay. In the meantime, what we can do is let's add one kind of up towards the top, a new test. Let's see here for all of our objects. Initialize raw data. Kind of want to add a new section, but this would mean I have to rename all of these methods, and I'm not really keen on that. That's fine. We can add it towards the bottom. Let's see here. So what we want to test the upcasting. So we'll say, what was the last one? Our last section is test 7, so we'll do test 8. Actually, we should probably move this into its own test category, but I'm not really worried about it right now. I just want to get it done. Okay, so what we're going to do, how do we set up this stuff before? We set up our new interaction mappings, we do some stuff, we do some other stuff to it. Okay. For now, let's just take a look at our single, no, we want to test the dual axis one. So let me just grab this one. We're going to initialize a new vector2 mapping. And one other thing we want to do is we actually want to pass in our processor somehow. So let's see here. I'm going to add an internal setter for this, just so we can get the tests working. No. This needs to be initialized in the constructor. My apologies. Let's not do that. Let's do it correctly. Okay. So that's what we want to do. We're going to say this is null initially. And if it's null, then we'll just set the default value, which is an empty list. Okay. Let's see here. Probably want to do the same thing to all these. I may actually go ahead and add this to the base constructor and then make everything else roll this up. Yeah, that's what we're going to do. Yes, add it to the documentation, please. I wish it would just do it automatically when I pasted that in. That would be nice. Let's see here. This one's going to be a little bit more difficult because I'm not really sure how we're going to handle this. This isn't being used anywhere? Never used? Really? Oh, that's right. We removed these two parameters. All right. The important thing we need to remember is that in our defined controller interactions, we need to make sure that anywhere that these were flipped, we need to make sure that we're actually updating the processors. So it looks like the Xbox One. Yeah, we'll take a look at these. That'll be part of our pull review before we push to our next changes. We'll make sure to look those over. Let's see here, and then also so essentially what we're doing is we're replacing those Boolean flags with our processors when we get there. Gotta get there first though. All right. Come on. All right, make sure we are calling the base constructor type for these, and then here the important thing we need to do is make sure that we don't have any existing mappings. Here we go. The other thing we want to do too is make sure that the state change type is the same as the mapping as well. The rest of this should be generated. Okay. That's going to be set. These are set. I'll come back. I'm not really worried about sorting those out yet. Okay, so now we got the right constructors. See, we updated a bunch of classes because we are no longer doing some things. We'll come back to those. Okay, now for our tests. How do we want to do this? I'm actually going to create a new instance just right off the bat. Because what I want to do is create my own list here. So hold on, input processor. And this is a scriptable object, so we need to do create instance. We can't do like new. So all right. So one other thing we need to do, we will have to make this a setter. We'll have to add setters to these because with the scriptable objects, you can't pass in a constructor, which is frustrating. So that won't work. I would love to have a constructor, but that is just not possible. But we want people to be able to set whether or not they can invert the X and Y axis values on the processor. So let's go ahead and make sure we're setting the input processor's insert X to true, and then we'll pass in this to a new list. Not worried about this guy. we're just going to pass in our one processor here for this. Okay, and then what we want to do is interaction, get input processors for type. I'm going to say vector 2. And then what we want to do is for each of our processors, which we know is probably right. Okay, we only have the one, but I'm not worried about it. Let's see here. You want to say processor. Is it going to give me back the right thing? It's not. We want to return type T. There we go. That's more correct. Now we'll get the right thing. Yep. You can get process. I can't get the flag that I want though. Let's do a for loop instead. I also want to make sure we're getting the right type out. I read only list input processor vector 2. Okay. So I'm not seeing the flags that I want. I'm not sure why. Oh, I know why. They're not going to be here. We need this type. We need to get this type out. So that is a little bit different. So what we expected to get back was this type, not the generic type for it. So what we really want to see is a list of the inverted dual axis processors. Oh, actually, you know what? No, this is fine. What we want to do is if our processors, I'm going to go back to the for loop, or I'm sorry, for each, because it'll just be, I don't have to worry about the, no. Go back to the for each because it'll just be a little bit easier to deal with. All right. So for each input processor, if input processor is invert dual axis processor, and then we can get the type, invert dual axis processor. There we go, invert X. So this is what we'll be testing here. Assert is true. We'll say invert, yep. All right, so that should be what we're doing. I'm going to go ahead and do this to a for loop after the case because it looks like that does do some allocations for whatever reason. This is a little bit convoluted to get whether or not the axis is inverted though, so we'll see what happens. All right, so let's test this one out. Let me make sure I'm still running my stream here. Is the stream still healthy? It is, great. Okay, cool. So let's go ahead and test this out. I'm going to go back into Unity. We're going to go to our test runner. And then we're going to test out our new processor here. All right, so let's go ahead and run this. And it checks out. So that worked, Jared.
What worked?
Casting it like we did. So this is what I ended up coming up with. So we were able to get this out. So we were able to go through and we can cast it to the generic type, which is fine. But the thing I ran into really early on, I noticed that this is actually the type that I want to get back out of this.
Yeah.
Not the generic type, which is kind of interesting. So I'm wondering if I want to do kind of both.
Well, you're
this,
just using
this
an
will pass
is,
in a collection
right?
of all of the processors that have a generic constraint with vector 2. So this would get all of the processors that process vector 2 data. But what I would really like to do as well is be able to get the inverted dual axis processor type back out too. So that'll be interesting. So that's going to be my next test. Let's see. So we tested our generics. I'm going to just copy everything we got here, and I'm going to create a new test.
Well,
directly
yeah, I'm talking about implicit casts, not explicit casts.
Yep, I think it's fine the way it is. I was able to do what I needed to do with it.
I mean, yeah, that's fine.
Yeah, so this worked out. This is what we wanted. I just wasn't sure if this was going to, casting it up like that, I wasn't sure if it was going to work, but it did, so it was great.
Yeah, it won't do it implicitly though.
Yeah, I'm not worried about that. I was just worried about getting all the processors out for the types that we had expected. We can add some more tests here too, so we can say, like for example, we know that we only passed in one input access processor, so like the count here, like that's another test we can do, make sure that the number that we got out is correct. That'll be something we can test later. Actually, you know what? Let's do it right now. What was the other one that we had created for this? The single axis processor? And I'm actually going to move this out here. Created processors. That'll be better. And so this will be interesting. So now we'll add both of these. One thing I want to add here is another flag. We actually want to add a private Boolean flag here, which is invert. All right, so that should be a little bit better. Okay, so now we want to add created processors. We want to add both our float axis processor and our dual axis processor. All right, and then let's see here. So this should come back as 1, and we should still get the same thing here. I also want to go ahead and add the new tests that I wanted to do as well down here. What was it that I wanted to test? Oh, that's right. So I wanted to also be able to pass in this invert axis processor. So instead of saying, okay, well, I want the vector 2 dual axis processors, but I want processors that are of this type. I don't know if that makes sense. So I don't have to go and loop through all the processors and to make sure that they're that type. Does that make sense? So I should be able to do this. You know what? I might actually have to make a new. I'm gonna have to make a new one here. This will be something similar but different. So what we want to do for this one, we'll be passing back the type that we're looking for. So it'll be a list of processors of that type. Same, but different. One of my old coworkers used to say that all the time. It was great. Oh, we do want that one. We want to cast it to T. I'm not really sure that will work the way I want. Where T is the input processor. See, it's still gonna get mad. Oh yeah, we need to change the name. And then here, I think we still need to cast 2T. Yeah, that's what I thought. I just need to add this is where the constraints come in handy. Love working with generics. Generics in C# is definitely one of my favorite things, for sure. So with this one, I do need to add some constraints for this to make sure that we're only passing in value and reference type reference types instead of value types. I want to say I did that with the input actions event data at some point. I just need to figure out exactly how I was doing this. Yeah, I gotta remember how I did this exactly. It's been a little while, but I think we can add constraint types for these as well when we when we're raising those events. So I gotta take a look at that. I know somewhere I can remember the constraints for those. It's just been a while. Okay. Maybe it's in the input system. Reality input system. Let's see here. It's in our generic input events that we were doing this. Position changed. I know these are pretty solidly written. Yeah, I'll come back to it. I'm not too worried. Okay, so now we can get our processors for our specific type that we're looking for. So we want to get all of the dual axis processors for our interaction. And this should come back as that. We only list input processor. No, that looks wrong. Oh, no. Yep, that's why it's wrong, because we don't want that there. This is where the constraint is supposed to help, where T is a struct. Let's just do that for now. That should be enough. of a constraint to make sure that this actually isn't available. So I can say float now and it'll work. But now if I pass in the processor type directly, obviously that won't work because we want to use get input processors of type instead. There we go. So that should resolve correctly this time. I also want to kind of add what we did up here to this top part. So I'm going to copy this. I'm going to come back down and we'll paste this here. And then also want to add the assert where we're only getting a single one back out. And we can get rid of this line. All right, so now we can go ahead and now we can test this case now. So we're just going to say test, that's testing the generics. Test get processors. Test get processors of generic types. All right. Get processors of specific types. All right, cool. So I'm only going to run the last two tests since those are the only ones that I'm really worried about at the moment. All right, so let's go ahead and run the generic type test. That one passed. Great. We'll run the getting of a process of a specific type. All right, well, it looks like we got some problems here. So what happened? Expected true, but was false. And that's on line 1144. So let's take a look. 1144, we didn't get one back like we expected. We got multiple ones back. So there's something else going on here that we're not expecting. So what happened? I think it's because we got this generic type constraints. We're not really worried about that. What we're actually more wanting to test is whether or not the input processor I get type is the same type here. So this should be better. So we were doing the wrong thing. We were getting the generic type arguments, and we weren't. We just need to know what the type is for that processor and whether it matches the type we're looking for. Wow, we're going 2 hours on this stream. I might take a break here in a minute once we get this working. Cool, there we go. So now that worked. So now we're only getting the type we expect back out. So just some cleanup, let's go ahead and add some documentation to help people understand exactly what this is doing. All right. Get the input, excuse me, processors for a specific axis type. So whether it's a single axis, which would be float, Boolean for digital, you know, all of those things. Okay, so that should work. Let's see here. I want to do more than just struct though. Like structs really work for the most part to like help constrain, like, you know, the basic types like, you know, vector 2, vector 3, float, quaternion, all these guys. But I want to say that there's something that should be added to the constraint that makes it so that I can only do like these values. But you know what, at the same time, we don't want to do that, because if someone else wants to create their own value types that they want to use to process data, like say, for example, we have hand data, which that is also a struct, or some other thing that holds some sort of input value, we should be able to let people be able to do that. So actually, I think that this type constraint is probably fine.
What about raw data? Because we do support
It's an object
objects.
type, which is a struct, I believe.
Objects are not structs. Objects are references, I thought.
There you go. Oh, you're right. So that is going to get mad. In that case, I would say that's not a case I want to. No one's using that anyway for the raw data. You have to do a bunch of boxing anyway. It's really not ideal. We really want people to utilize it.
I agree 100%. This should only be for value types anyway.
Yeah. I believe we can use float here. Right, Boolean. Good call, Jared. That was actually a good point. I didn't really think about that.
Yeah.
I wasn't really worried about the raw object value types though.
But the only other thing I can think of is matrices. I think matrices are ref types, but I don't know. If you're processing matrices, I think you're in the wrong place.
Yeah, probably.
In general. Those are the only two things I can think of.
Let's see here. So, what was I doing? I was finishing writing the documentation here. Get the input processors for a specific processor type. We'll give an example of like the dual access processor. All right. So that should be fine for now. I can add the more documentation later. I'm not too worried, but the return types obviously are. I'm not too worried about adding that stuff. Okay. So that should work. This will also fix the problem that we were getting before. But I do want to cache these somehow again. Like that's an important thing. I got to figure out how to make this a little bit faster. Really, I'm more worried about the input processors for type being slow because we do some reflection-y type things here that I'm not too keen about. Right? That is reflection. Doesn't look like it, actually. Does this generic type arguments, is that not part of?
If you want to make it faster, you could try inlining it, adding like inline attributes to your methods, or like the actual processing methods themselves. And yeah, not use reflection. But I don't think you're using reflection in the actual processor. No, you're not. You're only using it like in the UI and stuff, which is fine to an extent.
I think once this is compiled, this is just an array of types that you can get out of your type. So I don't think it's doing reflection. I think by the time this does get here, it should be fine. The thing I'm worried about is nested types, but we do have a way to the max recursion depth, so this doesn't go down too far, from what I understand.
What do you mean nested types?
So what the generic type arguments, what this does is it iterates through every type, child type, and then it goes to the base type and then gets all of the generic type arguments for all the types down the tree for that type. I think I might just do one here. And what that'll do is the max recursion depth is only one time. So we'll only go down the one time. I think I can make this 0. max recursion depth is greater than 0, then find the other things. So I'm actually going to make this 0 because I don't think that will be going down too far. I'm going to make that change and then test this out one more time. Well, if somebody else derives more types from there.
That's what I was thinking.
Yeah.
Which I think you did once, but I don't see like a huge use case for that, unless like
yeah, that's not gonna work. We'll keep this at the default, which is 5. I'm not too worried about that. And I don't think we'll be using this in our runtime code too much. I think the one we'll probably be using more is this one here, where we get the input processors of a specific type. This one was kind of nice to have, I think. So.
Oh, what were you looking at? I thought you were talking about the input processors of a specific type.
Yeah, that's what I was looking at before. But I also made one where we were getting of the type. So if I go back to my tests here, so I can actually just get the dual axis processor out, or the processors that are of this type. Really, there should only be one of each type, but I'm not really going to adhere to that right now.
Processor, like, because these are just going to be like super fast like conversions, you know what I mean? Like if you want to do actual input handling, that should be done like in an input handler, right?
Yeah, what this does is it takes the raw values and processes them at one step and then sends that out to the controller. Does that make sense? So if we want to have a dead zone for a controller, things like that. So if I go back here, Unity, they have this axis dead zone, clamp, invert vector 2, 3, normalize, scale, and they have some stick dead zones. So we have those. For them, what they did was they actually have an interface, I think. No, I think theirs looks the same. I actually haven't looked at their code, so this is interesting to see. So it looks like they kind of do the same thing. They also have a reference to their input control. I'm not too worried about that. And one thing we're doing too is when we process it, we're actually using a reference instead of in ours. So if I go back to this, we actually reference the value.
Mm-hmm.
So we do ref2 because what we want to do is process the value in place. We don't want to make a copy of it in memory. We'll actually be directly manipulating that.
I would just make that process function right there like inline, because if you did that, it would just be a straight call to the
How do you do that?
I think it's an attribute. It's a method impl options. Wait, sorry. It's method impl attribute. So
can you type it in the chat?
Yeah. There you go. I don't think it's inherited, but they might just have to manually add it. You can choose to make it aggressive, but it's like most of the times your process function should be like 1 or 2 calls, you know, because it should just be like doing some basic math, you know.
Okay. We want aggressive inlining, is that what you're saying? But this is also abstract, so it's like a virtual call member. So I'm not sure how that's gonna work on this. Let's take a look at this one more time, the documentation. What does this do? Specifies details of how a method is implemented. This class cannot be inherited. Here's some examples.
If you look at the method impl enum, you have like aggressive inlining, a forward ref, or like no inlining and stuff like that.
I don't know if it'll be inline because it's a virtual call member, right? So if I go back, here. This is abstract. I don't know if you could inline those things, can you?
A quick Google search will reveal it all. I thought they could, because it just has to grab it from the V table. No, it can't.
Cool. All right. And this will go to all of the others? Or do I need to add this attribute to all of the...
No, it has to, because it has to resolve the call at runtime for the base class, so it can't inline it.
It can't inline what?
The process call. So yeah, there's no reason to have that.
Because it's virtual call member?
Yeah.
Yeah, that's what I thought. Oh well. Good call though. I mean, that would be nice if we weren't doing some weird things here. So I think one other thing that I want to do, I actually want to make this a...
I think they can slide it to their calls. Sorry.
No, I won't make this an interface. I thought about making it an interface, but I'm not going to. Because we want to use the scriptable object specifically as a way to reference this in our thing. So people could still be able to create their own types.
Mm-hmm.
So this is nice. We have a couple of different types here. So I want to actually move this class out into its own file. Let's go back here. I'm going to move this other one into its own file. Cool. I don't like that these are virtual method calls because it does probably make it slower in some way. But
there's some slight overhead to virtual calls, but I'm not really sure how you would mitigate that. You could
yeah, me neither. But it is what it is. I think the speed is still probably okay. We'll come back to that. We got it working though. That's the important part. But we are referencing the value, so that's good. So we probably make up for some of that here. I don't know. That'll be something interesting to probably check out in the future. All right. The other thing I need to do, add my headers for licensing to all these files. All right, I think I'm at a good stopping point. I'm done streaming for now. So whoever's probably watching this, they're not bored out of their mind. But so we got the input processors done. Let's go ahead and I'm going to review all of the stuff that I'm going to commit to this one. I do want to just double check, make sure all my unit tests still pass. So we'll run these one more time for our new classes.
I kind of want to stream too. Let me see if I have the. What does streaming use? Does streaming use your CPU, right?
Yeah. It depends on how you set it up. Mostly CPU. Cool. So these pass. Yeah. And then let's see here. I'm going to go back through here real quick. Some of the things we changed. I'm actually not going to commit the changes to the controllers where we change this because I want to go back and implement the processors in the controller definitions later. So I'm actually going to leave these alone. So the only things that I really want to add is the processors themselves and the tests, and make sure we've updated our tests. So I'm going to go back. I'm just going to discard any changes for our controllers. It won't compile, but that's fine. I want it to not compile for now so that I know where to go back and fix those things. Okay. Let's see here. I actually just want to go ahead and remove these lines directly in the mixed reality interaction mapping. So we'll go back here. So I can find it easier. I'm just going to discard these lines so that they throw errors. So I could just remove the lines outright. Let's see here. Those are serialized properties. We added our processors to our constructors. All right. Oh, I know what I'm going to do for now. It all makes sense. Okay, so for our float data, I'm going to have a list, private list. You know what? I'm just going to leave these aired out for now. I'm just going to commit what I have, and then in the next pass, I will go back through and kind of do the rest of these. So I'll know to update the interaction mappings for our processors, and then also update all of our controllers with the new processor types that we have. Right now, I think we're only using the dual, or we're just inverting. So our single and dual axis processors are the only ones that we had implemented in our current version of our mapping system. So we should be able to add the others later. So I'm not too worried. Go ahead and commit this, and then actually,
before you commit, do you want to?
These are actually living at. Let's see here. I want to do one more definitions thing. We're going to create a folder just for processors. So we had created these in controllers. No. Devices. We'll move these guys over into processors. All right, and one last thing I want to do before I finish up, I'm going to actually set the default icons for these guys.
Do you want to add a value constraint to the abstract input processor class?
That's a good call.
Just so no reference types can go through that.
That's a very good call. There we go. Good call, Jared. Appreciate you.
Mm-hmm.
And while I'm here, I might as well add the documentation for these two. Let's see here. Let's go back to GitHub. I'll go back to my issue. I had all these things kind of written out and described pretty well. So there we go.
And do you need a ref keyword for a value type? Does that do anything?
What's up?
You had a ref keyword with a value type. Does that do anything? I don't know.
Do you know what ref does?
I thought it's passed by reference, not by value.
Correct. Well, I think you said it backwards. I'm not really sure. I know what it does. I just can't remember what the specific language about it is. Passing an argument by reference.
Ref struct types.
Yep. So we reference the...
it's a stack allocated.
Mm-hmm.
Oh, no, that's actually a good thing. Yeah, keep that.
Yep. That's why I was using it. That's why I was saying that where we would, even though we're using a virtual method call here, we probably save some by using the ref keyword.
Well, yeah, because it loads it onto the stack, so whatever function you call next, it doesn't have to like reference it out of the function again. Basically, it's like 2 extra calls that it doesn't have to do.
Exactly.
And it just puts it on the stack, so it can just send it to the next function.
Alrighty, all right. So let's take a look here. Okay, so I think that's everything. I went ahead and moved the processors into their own folder. don't think I have anything in here anymore for this. Yeah, so now the processors get their own things, which is nice. Oh,
Yeah, and it has a bunch of constraints on it that make sure that you don't put it on the heap, because that would be redundant.
Yep. All right, cool. So this looks good. I'm going to go ahead and stage that guy. All of our input processors are in, and they have our nice mixed reality toolkit icons, and I'll go ahead and add this. Added input processors. Cool. All right, well, that's it for me for this stream. I think I'm going to go ahead and call it a day here. I appreciate you guys joining in if you were tuning in. Thank you. And we're going to continue working on this input controller refactor. It is that pull request 494 in the mixed reality toolkit. Thank you guys for tuning in, and see you next time.